some applications here and introduce another idea about the normal and standard normal distribution. Then we will be the last idea we'll be discussing about the uniform distribution. But now let's go over these examples. The time it takes an emergency response team to arrive at the scene where assistance is needed is very important to the medical outcome. In a particular city, data show that the mean response time is 4 minutes. This is very important. Now look at the data. Look at the key words. The mean is 4 minutes. So this is the mean. Standard deviation is 2. Another important piece of information, the response times are also shown to be normally distributed. This is relaxing piece of information because now you can use the functions we used for Excel, right? And EMT directly pulled data for 3 emergency calls and found the following responses times. Call 1 4 minutes, call 2, call 3. The question is very simple, ask you to standardize these values. Standardizing, we can use the formula quickly, or you can use what we call the Excel value. So mu is given to us, which is 4. Standard deviation is 2, right? So we can standardize these values. Either use the formula Z equals x minus mu over sigma, which is equal 4 minus 4 divided 2, which is 0, which is correct. Standardized value for this value is 0 because it's the mean, it's in the middle. Or you can use the standardize equal Excel standardize 4, 4, 2, I think. Yes, that's it. We don't have true or something. Yep. Then you should get the same answer. Number 2, and you can basically graph the guy, by the way. Number 2 is Z equals 5.5 minus 4 divided by 2, which is 75%. The last one, 3, is Z equals 2.3 minus 4 divided by 2 is negative 1.7 divided by 2, which is negative 0.85, I think. Yeah. And if you compare this graph, which is the normal distribution, to the standard normal, now we have the Z values, right? So this is the normal, standard normal. And this is the Z value, standardized. This is the 0. Again, if you look at the 4 is here, the mean 4, and the 4 is here. 5.5 is here. 2.3 is here. It's going to be exact location here. This is going to be here. This is going to be here. Okay? Example, next one. The question says, after completing a study, Chicago airport managers have concluded that the time needed to get passengers loaded onto an airplane is normally distributed, keyword, with a mean equal 15 minutes. I don't know where's the dot from. It's 15 minutes. Standard deviation 3.5 minutes. Recently, one airplane required 22 minutes to get passengers on the board and ready for takeoff. Find the probability. Look at this. Find the probability that the flight will take 22 or more minutes to get passengers loaded. Let me convert these words in the blue into math statistics terms. The question asks you to find the probability that x is greater than 22. 22 or more. If you would like to put equal, that's fine, but it doesn't change anything. This is the question. But the question asks, actually, I will also give you what? The mean, and give you the standard deviation. So if you graph it, it's normally distributed. The mean is in the middle, 15 minutes. 20 minutes is going to be somewhere here. The question asks you to find the probability that the flight will take 22 minutes or more to get passengers loaded. So we are looking at this area, the right-hand side. But as we said, Excel doesn't know the right-hand side. Excel can give you the one in the left of the 22. So what we do, we get 1 minus. So equals 1 minus norm dot dest 22, 15, 3.5, true. Then we get the answer. So let's find the answer. We got about approximately 0.022. So it's about 2%. 2%, so 22. Actually, there's low chance that we are going to exceed this number, so it's 2% only. This is a similar example. We have less than, we have less than, we have between two values, we have more than. So we have the standard deviation and the mean. So actually this is an example. We did something similar in the past. This is the same thing. We're looking for the probability that x less than 7.5. And we're looking for what? This is we have to look at the normally distributed stuff. Data are normally distributed. Where's the mean? The average of 8 hours. And the standard deviation is 0.4, right? So actually you can read and do the question again. This one is a bit different, so let me pause here and do another example. Okay, suppose that I ask you that let's work on the z first. Or let me do what? Let me do it in another video. So we have another idea in different videos. It's going to be much better than this.